I handed you out two things. One is an assignment, the other is a cheat sheet. And if you don't know already, I do want to credit Cheryl for that. Cheryl took time out of her day to put that together for you. Thank you, Cheryl. Thank you, Cheryl. Hi, Jan. Got an MTC?
Yes.
You're going to come experience the class today.
Yes, for at least 15 minutes.
Okay, well, sit up closer. Because,
Sit up closer.
Yes.
Where do I need to sit?
Anywhere, but you got to get into the conversation.
Uh-oh, that's scary.
Okay. So anyway, we are going to complete the trig cycle today. So far, we handled right angle trigonometry in our formula for it, SOHCAHTOA and Pythagorean theorem. Because that ought to be the first question you ask yourself whenever you're dealing with an angle. Am I going right angle or an oblique angle? Okay, and that's going to decide that. Now, if you decide you're going oblique, then we really have four situations that we need to deal with. The law of sines that we've handled the last 2 weeks handles two of those cases. The last two are handled by a derivation called the law of cosines. Now, keep in mind, when you say the law of sines or the law of cosines, what does that mathematically mean? Does anybody know what that means?
Wait, could you repeat the question?
If I say something like the law of sines or the law of cosines, mathematically that terminology has a distinct meaning.
It's the same all the time?
Exactly. It has been proven to work every time in those situations. They don't call it the theory of sines or the theory of cosines. So have faith that these equations will work for you every single time. If they do not work for you, then guess what is probably the problem? Logic. It's logic. No, it's operator error. Right? It's operator error. They work for you all of the time. Okay. If you are interested in the derivation, it is in your textbook on page 53, this top section up here. In essence, they use a right triangle to prove or derivate by that come up with the law of cosine. The previous page is the one I showed you a couple weeks ago where it has the derivation of the law of sines. Okay? That's as close as we're going to get to deriving an equation in here. This is applied, we are going to apply it. I want to introduce the law of cosines off of Cheryl's cheat sheet that I handed out earlier. Okay? So I'm going to come to this, and let's make sure we know how to run this cheat sheet. You might be able to use this for your students.
Perfect.
Okay, so the way this is broken out, law of sines is on the left, law of cosines is on the right. Now the first thing, whenever you are dealing with an oblique triangle, so you've looked at a situation, said I need to solve for some unknowns, I've determined it's not a right triangle, I'm going oblique, I come to this sheet. Again, I do not expect you to memorize any of this, but it wouldn't be a bad exercise if you did. The thing you need to do is know how to use this piece of paper. Okay. Law of sines we've already covered. Now I gave you a cheat sheet for this 2 weeks ago. We've edited this and produced a new one based on students and their recommendations last year. Okay, so we've made it a little bit better. And the part that we edited is this part over here, law of cosines. Now, keep in mind that they come through in the situations when we use these. I do want to clarify one thing that came off of this one. Okay? So we have up here, whenever we have an oblique triangle, and I've got this situation where I know two sides and an angle, then I'm going to be using the law of cosines. But there is something you need to clarify on there. That angle that you know must be in between those two known sides like they have shown here. So I don't know if you want to make yourself a little note there. It's not any angle. It must be the angle in between the two sides. So we'll probably make that update for next year. It's a process. The other time I will use the law of cosines is the one on the right where I know all three sides of an oblique triangle, none of the angles. Now, your law of cosines is given to you right here. This is the equation that's sitting in your textbook. Based on the assumptions that we had last year, when you take this and you try and isolate the angle off of it, like angle A or angle B or angle C, you have enough algebra to isolate that to fill a page worth of notations. We saw a ton of errors coming off of it. Last year, a student, like I said, had a great idea and said, why don't we just derive all these equations where the angle is isolated? Because with the law of cosine, you're either looking for one of two things, one side or one angle. That's it. So you can derive it to work in both instances, and we get rid of all those algebra errors. Hence, this right here is the law of cosines also. The exact same two equations.
Oh.
This one solving for side A. This is the same equation rearranged to solve for angle A. Same equation. Same equation, B and B. It's just been changed so that you are looking for the angle or the side. But we're getting rid of all of the algebra for you with these. Okay, it's a nice little cheat sheet for that. Okay. Now again, when you label the triangle, you must do it this way. Same as we talked about with the law of sines. That does not change. So in essence, what we're doing here is we call out any angle. The side opposite must have the same letter but lowercase. Sides get lowercase, angles get higher case. Okay. So in essence, here you go. All possible situations. Now, just to show you how this works, let's look at this situation right here. If I know a side, and the angle in between them. Now, if I was to look at my little equation here, let me just go ahead and label this one. So I'm going to call that A, that means that's side A. I'll call that B, that's B, C, and C. Now, just to show you why this works, now let's go ahead and put this into this equation right here. Okay, what do I know here? I know angle A, right? So I know that portion. It's telling me right here, you know it. Okay. Now I know sides B and C, right? So I now know that portion of the equation. I also know that and that. What am I looking for? Are all terms, all variables accounted for? And I've only got one unknown, therefore I can get a determinate solution. That's why this situation works. Okay, now let's just look at the sides here, and I'll come to, let's say, this one. If I know all of the sides, doesn't matter what I label them here, do I know everything? Let's see. Oh, sorry, I'm on the wrong one. I know all the sides, I'm looking for an angle. Do I know everything over here? I do. Okay. So therefore, again, I can solve for the unknown. That's why this situation works, and what this equation takes care of, versus this one to handle the other possible cases you can have. Any questions on this?
So you use the bottom formula for angles and the top one for side angle side?
That's correct.
Okay.
Yeah. When you get into your, you're given your found section, you say, what am I looking for here? Where's my math problem going to take me? On our little outline, and you say angle, you're using those bottom three.
Okay.
Okay? All right, let's run through a couple situations in this so you have some examples of it. In your text on page 59. Any questions so far? Questions 3 and 4 are both law of cosines problems, so let's work these two. We'll start with question 3. So, construction technology. A triangular traffic island has sides of 21.5, 46.2, 37.1 feet. What are the angles at the corners? So in essence, if we go ahead and draw this thing out, and I'll just put it like this, where's my longest side is a 46.2, my next longest side is 37.1, my next side is what, 21.5. Okay. Now the first thing we look at, is it a right triangle? No, it's not. What would be a hint that it's a right triangle? How about I had a couple sides that were equal, right? 45, 45, 90, something of that nature. In this instance, we're assuming it is an oblique triangle. So once I do that, I know I'm going to my cheat sheet. So I go to the cheat sheet, and we're looking at across the top of both of these, law of cosines, law of sines. Are one of these conditions met as we come through here? Angle, angle, side, angle, side, angle, side, side, angle?
Nope.
None of those are met? Come over here, side, angle, side? Nope. All sides?
Mhm.
Got it. Okay, that's the one we're using. Now we've taken 10 equations, 4 for the right triangle, 6 for the law of our oblique triangles. We got rid of the 4, not a right triangle. We got rid of all 3 of these due to this. So we've gone from 10 equations down to 3. Okay? And this is how we're kind of just isolating things so we don't make a bad choice. So we know we're doing the law of cosines. The next step, label your triangle. Okay? So I'll just go ahead and call some out. Let's go A, B, C. Therefore, this is A, this one's B, this one's C. Again, it does not matter which one you call A, which one you call B, which one you call C. It matters that the side opposite the angle has the same letter. What are we looking for?
The angle.
Fine. Looking for angle A, B, and C. It asks for all 3 of them. Okay? We know we can do this with the law of cosines. Therefore, let's just pick one. Okay? So again, I'll come back to my cheat sheet. And I don't know, Declan, which one you want to solve for? Angle A, angle B, or angle C?
A is fine.
A is fine? Here's our formula then. We've already got it in the situation we got. All we're doing here is plugging and chugging. Now, as you use this, based on your calculator, one thing I'd recommend, folks, with the law of cosines, you got a couple things you got to watch out for. One, do all of this and get a number before you take the arc cosine of it. Most of your calculators will work better in that format. The other thing you must really pay attention to with the law of cosines is you have a negative number here. And that has to be tracked through the equation, because cosine will be an indeterminate value in the second and fourth quadrant of a circle. Okay? It's only the first and third. But you got to watch that negative sign. Okay? Are we good on that? Let's put it in action. Okay? So we know the equation we're working with. Let me just get this off. So we're using A is equal to the arc cosine of, correct me if I'm wrong here, A squared minus B squared minus C squared. There's a negative here, and that is 2BC. Did I get that right?
Yes.
Okay. All right, let's plug in our numbers now. So we know A is equal to, and again, I'm going to stick with that nomenclature. I'm going to try and get a number here. A squared. And these things are going to get really big on you, folks, so make sure you take time to do notes or whatever. Minus B is 21.5 squared minus my last one, 46.2 squared over 2 times B times C, 46.2. Okay. For the first one, let's track each number through. Okay. So what I'd like to do is, let's take this and first expand these numbers. So can somebody give me what 37.1 squared is?
1376.41.
76.41. Make sure you holler this, please. Is that right? 1376.41?
Yeah.
Yes.
Okay, minus
462.25.
minus the last one.
$1780.84.
Okay, did I get all this right?
The last one is
Did I mess it up?
34. 2134.44, did that one?
42.
21,
34.
0.44.
okay. Let me pause right here for a second.
Oh,
Everybody
you're
make
right.
sure you see where those numbers come from, and you can get them. And let's discuss any that aren't working. You got any?
Yeah, I got it.
Okay. Declan?
Yeah.
You good? Okay. All right, what's 2 times BC? What's this number? Somebody got that one?
1986.6.
1986.2. Okay.
0.6.
0.6. I knew that. Okay. All right, let's take the next step. Let's reduce this to one number up here. So let's take the top one and reduce this number. Now, you're going to get, I can tell you right now, this is 1376, right? This number is larger than it, it's being subtracted, this one's being subtracted, it should come out a negative number. We're going to want to pay attention to that. So whoever gets that top number, please let me know what it is. I'm sorry, say that again.
Minus 1220.24. Someone confirm.
1220.
0.24.
I got 0.28.
Yeah, I got 0.2.
Yeah, 0.69.
Okay. And decimal place probably, right? We'll stick with the majority of you. Now that's a minus, right? And we're over 1986.6. Now, so here's where I need to pay attention. This came out a minus, so I'm going to do a minus and a minus. This now goes positive, correct? So in essence, now I'm sitting with A is equal to cosine minus 1 of 1220.28 over 1986.6. Because I have a negative times a negative is positive. Now we can reduce this number. Again, we go 2 decimal places in here, right? 0.61. Okay. How do we get the arc cosine of it?
You go second.
Most of you, yeah, second function cosine, right? A is equal to
52.10.
52.80,
10.
0.10, and that's degrees.
52.41.
Decimal problem. Yeah, same answer. Questions? Now, if you have calculators that can do all this as a formula, you don't need to reduce each step. If you do reduce these numbers, remember, I will hold you to 2 decimal places. You do not have to reduce them and carry 6 decimal places. Go to 2. That's accurate enough for what we do. Y'all good on that? Okay, so now we have an answer. So what we now know is that this angle is 5.2, oh, sorry, C, not C.
See, if you just stuck to the naming conventions.
Yeah. How are we going to find angle B?
The same way, but like in a different way.
If you like doing that,
Or-
You no longer have to use law of cosines now, though.
Oh, you got signs now.
Okay? Now look at your law of sines situations. Do we have one that has two sides and the angle opposite one of them? The law of sines is much easier algebraically to use. There's a lot less terms. Now, certainly where we've rearranged these equations for you on this new cheat sheet, if you got a calculator that punches it all in, then hey, just use it. Most of the time, people will do the law of cosines and then jump to the law of sines for the other one. So that would say, let's say it gives us B. Now, do I need to do the law of cosine or law of sines to find angle C?
No, because you just subtract it out.
180 minus, right? Okay. In essence, now we know everything there is to know about this triangle. Okay, is that good? In your text, let's look at problem 4. I'm not going to do the law of sines, we've already done it. So here we have a little surveying problem. Property boundary. A lot shown is split along the diagonal as indicated. What length of fencing is needed for the boundary line? So in essence, this is a trapezoid, right? Did I get that right? Where we've taken a square and pushed it over a rectangle? So we got a diagonal. Your angle, if you can't read that, is 118.2 degrees. We now know it's not a right triangle, just from the diagram, and I'll use it. What are we looking for? The diagonal, right? This guy right here. So find is my diagonal. Go to your cheat sheet. Here we have two sides and the angle in between. Okay, that's the other case for the law of cosines, correct? Now here, we are solving for a side, so you're going to use those top three equations, not the ones that have been derived for angles. Which one are you using? Well, you got to label your triangle first. Okay? So let me redraw this triangle so it looks like the one in the text. Where we're 87, 124, right? And this angle is 118.2. Just to be different, let's call that C instead of going with A. Is that okay, Eddie? You're usually my angle judge here.
I just had this
B, A, so this is C, A, B. What are we trying to find here?
Little c.
Trying to find little c. So we're going to move to the solution. Our equation is going to be c squared is equal to a squared plus b squared minus 2ab cosine of c. You know everything on this side. Now, one thing to also pay attention to at this law of sines. You have this whole number, which is added to that whole number. So we use addition, right, for here. Now when I come into this part where it says 2ab cosine c, that's all one number. You must be timesing this stuff together. So when I put all these in, I'm going to use quotes for saying I'm timesing this number by this number by this number. Okay? Again, pay attention to that character. It is going to get you if you don't. So let's put our numbers in. So I got c squared is equal to, and again, your numbers are going to get very big here. Minus So let's see, let's move all these down. Into this row. So, somebody got 87 squared?
7569. $153.76. Yeah.
76, and it's an even number?
Yes.
Yeah, it would be. Okay. Minus. And this might come up a negative number because of this cosine angle.
Negative 10195. 195.76.
Okay. All right, let me pause a moment. Please confirm those numbers that you're able to get them. Your 15 minutes are up. Where's that crunching number? Are you ahead now?
We are ahead, but I gotta keep us ahead.
You getting it, Missy?
No.
Okay.